Hello everyone. In the last video, we have seen how to calculate the lateral load carrying capacity of a pile by using Rees and Matlock method. In fact, piles can be categorized as a free pile or as a fixed pile. What is the difference between free pile and fixed pile? If you have a pile embedded into the ground, say this is the pile, this pile is embedded into the ground. So if you apply a lateral load or horizontal load, it is going to deflect like this. With the deflected pattern of the pile. So pile is going to deflect like this, and you have the deflection right at the top, and the deflection is going to change across the length of the pile. But if it is a fixed pile, say this pile is embedded into the ground in such a fashion that you have a capping over it. There is the beam, or all the piles are connected such that when it is embedded into the ground, if you see the deflection pattern, how it is going to deflect is, it is going to deflect like this. So what you are going to see here is that the pile is going to shift laterally but there is no rotation permitted to the pile top. So here in free pile, you permit the horizontal displacement or horizontal deflection, as well as rotation of the pile. This is permitted. And if it is so, this pile is called a free pile. But here, when you apply the lateral force, and here only there is a horizontal deflection is permitted at the top, so you can see here there is only horizontal displacement of the pile top, but no rotation. No rotation at the top. So here at the top, the slope, if you draw a horizontal line, slope will be 0. Therefore, slope at the top is going to be 0. But here the slope is not 0. Rotation is permitted, and therefore slope is not 0. It's going to change across the length of the pie. So that's the basic difference between fixed pie and the free-headed pie. So this is called free-headed pie, free-headed pie, and this is called fixed-headed pie. Fixed-headed pie, and these are the necessary conditions. These are the necessary conditions. So you can differentiate between the fixed-headed and the free-headed pie. So if you see the equation of deflection, so what is the equation for deflection? Over the any depth z, it is a function of z. The horizontal deflection is going to change over the depth z. I have already given you the equation for deflection. The deflection is given by a deflection coefficient Ax into Qz. Qz is the horizontal force that is acting at the GL, ground level, into relative stiffness factor Q divided by EI of the pile material plus Bx into mg T square upon EI. This equation you have used in the previous video, and you have found out the deflection, or if the deflection, permissible deflection is known to you, you can find out the lateral load carrying capacity of a pie, free-headed pie. But if it is a fixed-headed pie, you know the slope, the equation of the slope. I had given you that the slope is a coefficient for the slope, a theta, into Qg T square upon EI plus d theta into mg T divided by. So now if it is a for fixed headed pie, that means no rotation at the top, slope is 0, so slope will be 0. So if you equate this to 0, then what you are going to get over here, if you simplify it, then you can find out that this moment can be written as mg T, EI can be cancelled out, slope is 0, so EI can be cancelled out. So mg into T equal to minus a theta Qg T square upon b theta. Now the value of a theta and b theta can be obtained from the chart given by Rees and Matlock or from the table. So at the ground level where the slope is 0, you can find out at ground level, capital Z equal to 0, and there you will be getting A theta equal to minus 1.623, and B theta also is given as minus this quantity over. You can get it from the Reason MATLAB table. It is minus 1.750. This is the value of A theta and B theta. So if you substitute this value of A theta and B theta, because the slope is 0 at the ground level, then you can find out the value of mg. So therefore, you can get the value of mg, moment, equal to minus A theta by B theta. The ratio is 0.93. On substitution, you will be getting this value into QZ into T. So this is the value that you are going to get it. So if you substitute for fixed headed pi, if you want to find out the deflection, the general equation you know that there will be a deflection coefficient Ax Qz Tq upon Ei. Now there is going to be Bx into mg into T square. Now mg is here. Mg is here. So minus sign will come when you substitute it. So minus Bx, okay, minus Bx, and mg is given by this quantity. So you can substitute it as 0.93 Qz into T. So mg into T square. So T square into T becomes Tq divided by Pi. So this equation is for deflection for fixed headed pi. Now at the site, if you have a pi and you want to find out the maximum deflection, then you already know these values under the given loading, horizontal load applied at the ground level. T you can calculate it, relative stiffness factor. So Reason MATLAB can be used for fixed headed pi 2. So any long pi which is given, the criteria is L by T must be greater than or equal to 5. You can solve any problem for fixed headed pi and free headed pi. So fixed headed and free headed pi, any problem can be solved. So this is for long pi. There is also a method given in IS 2911 part 1 section 1 2010. You can find out how to find out the deflection and moment. So deflection and moment can be found out for both free-headed pi and fixed-headed pi. So IS code method, you can use it. So any pile, let's say this is free-headed pile embedded into the ground. And the horizontal force QH is acting at some eccentricity E. Then you can find out the depth of fixity for this pile. This pile is a free-headed pile, and you know the deflection. So the deflection will be 0 at certain depth. So deflection is practically 0 at certain depth, and that is called, from the ground level where the deflection is 0, it is called depth of fixity. So this is called ZF, depth of fixity. So if you see the IS code, you can find out the value. Here the criteria is for NC clay, normally consolidated clay, or for sandy ground. The depth of fixity can be found out. So for this normally consolidated clay or sand, you can find out the value of T as the fifth root. You already know is going to be EI upon eta H. So this can be the unit of T relative stiffness factor will be in meter, and you can calculate it. But if the ground is pre-consolidated or over-consolidated, then you will have to find out a relative stiffness factor known as R. So this R value is given in the IS code, which is the fourth root. This is the fourth root of EI into a constant modulus K into B, where B is the lateral dimension of the pile. So the lateral dimension of the pile is B, or if it is circular, it can be written as D. So these two criteria, you will have to see the ground condition and calculate the value of T and R, and then you know the point of application of the horizontal load over the pile, so you can calculate E by T or E by R as the case may be, depending upon whether it is normally consolidated or sandy ground or it is over consolidated. So for E by T or E by R, you can refer the chart given in IS code. So you will be having E by T or E by R on the x-axis, and here on the y-axis you will be having the depth of fixity upon T or depth of fixity upon R. So you are going to have from this chart, you can find out the depth of fixity. The moment you get the depth of fixity, then the problem becomes very simple. So use this chart to find depth of fixity. So you are having a depth of fixity. Now, if there is a pile embedded into the ground, you know the eccentricity E, and you also know the depth of fixity now. So depth of fixity, this is the total length of the pile. The depth of fixity, you can find it out. Let's say this is the depth of fixity, ZF. So E plus ZF you are going to have. Now consider this pile as a fixed one here. So this is equivalent to a pile where in this is the fixed head, and the total length where this is the QH. So the total length of this cantilever becomes E plus ZF. So this becomes a cantilever. This is the fixed end of this pile. So you have found out the depth of fixity from the chart, and you know E plus ZF, you know QH, and therefore you can find out the deflection. If it is a cantilever, you know that QH into E plus ZF cube divided by 3 EI of the pilot area. So this will give you the deflection of free-headed pile. If it is a fixed-headed pile, then X will be QH E plus ZF cube divided by 12 EI for fixed-headed pile. And this is for free-headed pile. So you can find out the deflection like this. And this is applicable for long pile. That means you will have to calculate L by T must be greater than equal to 4.1, or L by R, if it is a over-consolidated, must be greater than equal to 3.5. So these conditions will decide whether a pile is a long pile, and if it is a long pile, then only highest code method can be used. And then you can find out the deflection. Based on the moment also, you can calculate. When the horizontal force is acting at a distance of E plus ZF, you can calculate the moment. Here, what would be the moment? QH into E plus ZF. And then once you calculate the moment, you multiply it by a reduction factor M, which is given in the IS code. This reduction factor can be calculated, and based on the moment, you can also find out the deflection. So there are two criteria. One is this based on moment, and another depth on fixity method, you can calculate it. So this is how you can calculate for a long pile the deflection. You can calculate the moment, etc., and then solution can be arrived at. Few problems we will be taking up in the next video so that this concept which is given in the IS code can be made clear to all of you. Thank you.